This is a problem. Find a Fourier series of the function fx is equals to x square in the given interval 0 to 2 pi. So this is the basic formula which are used in the Fourier series, and this is the Fourier expression of any function fx is equals to, that is, a naught upon 2 plus summation a naught an cos nx plus summation of n equals to 1 to infinity bn sin nx. So here we find only a naught, an and b. So the formula of students a naught, this is 1 upon pi, and the given limit of interval, this is 0 to 2 pi, and this is fx into dx. So it is also 1 upon students pi, limit 0 to 2 pi, and fx is given x square into dx. Here we integrate x square with respect to x. So this is 1 upon pi, integration of x square is, students, x cube upon 3, and their limit is 0 to 2 pi. So we can also easily calculate this. This is 1 upon, this is 3 pi, we place 2 pi on x, so this is 2 pi is whole cube minus 0 the whole cube. It also implies this is 1 upon 3 pi, this is 2 to the 4 to the 8 of pi cube, students, and this is pi to the power 3, this is pi, so this is simply, student, 8 pi square upon 3. This is the value of a naught. Similarly, we can find also an. So students, the formula of an is equals to 1 upon pi, and this is 0 to 2 pi, and this is fx into dx. So here we put the given function fx, that is fx is given is x square, and this is cos nx dx into cos nx into dx. Here we integrate, this is first function, this is second function. This is, students, 1 upon pi, first function as it is, so it is x square, integration of second, integration of cos, students, this is sin nx upon n, and differentiation of first, so students, differentiation of first, that is x square, this is 2x, and integration. I repeat again, students, all the terms we treat it as it, not calculate, that is, we integrate all the sin nx upon n. So integration of, students, sin, this is minus cos nx, and here n is whole square, minus differentiation of first, student, this is plus, this is minus, so next term is plus. So differentiation of 2x is, student, simply 2, and integrate again second term, so this is minus as it is, students, and cos nx integration is sin nx upon n to the power 3, and entire limit is, students, 0 to 2. So here we replace the given limits, students. So this is 2 pi, here we place, this is 2 pi is whole square, and this is sin twice n pi upon n, this is, student, minus, and minus, this is plus, this is 2, and x is also 2 pi, and this is cos twice n pi, students, and upon n square, and here this is plus minus minus, this is 2 into sin twice n pi upon n cube, and this is lower limit rest, students, this is lower limit minus. So here we place x is 0, so after multiplication 0, this is complete term is 0, this is minus minus plus, students, so this is lower limit minus. We on place x equals to 0, so second term is again also 0, students, and then this is plus minus minus, and lower limit minus is plus, and when we place x equals to 0, so this is sin 0, so this is 2 upon n cube and sin 0. Here we calculate this, student, term 1 upon pi, students, sin 2 n pi, as you know, this is 0, so entire first term is 0, this is 2 to the 4 plus 4 pi upon n square, and the value of, students, cos 2 n pi is 1. Next is Again students, sine 2n pi, as you know this is also 0. This is 0 students, this is 0, this is 0, and sine 0 is also 0. So finally these all the terms are 0 students. So in this case 1 upon pi. Next is this is students 4 pi upon n square. So here we cancel pi, pi. So last term is students, this is 4 upon n square. Similarly, we can also find the rest Euler's constant, that is Bn. So here you can also find Bn students. This is Bn. The formula of Bn is 1 upon pi limit 0 to 2 pi and fx is here, as you know, fx is given x square. This is x square, and in this term sine n x. Again students, we integrate this term. First function is as it is, that is x square. Integration of second, and integration of sine is cos nx upon n minus differentiation of first. This is students twice x, and integration of second minus sine n x upon n square. And first, as you know, first positive, second is negative, so third term is positive. Differentiation of 2x students, simply this is 2, and integration of sine. Integration of sine is minus cos. Minus is already, so minus minus plus. So this term is students cos nx upon n kq, and their entire limit is 0 to 2 pi. Can we place the students? 1 upon pi. We place the students 2 pi on x. So this is minus. This is 2 pi is whole square and cos twice n pi upon n. This is minus and minus plus. This is 2 into 2 pi into sine twice n pi upon n square students, and then next term is plus 2 into cos twice n pi upon n ka cube, and then students we place lower limit. This is minus lower limit. So on putting x equals to 0, so this is students x, so entire first term is 0, so this is 0. Next here student, this is also term 0, this is 0 on putting 0. Next is student 0 on this last term, plus minus minus on lower limit. This is cos 0, so this is 2 students upon this is n ka cube and cos 0. This is cos 0. Finally, this is also implies students 1 upon pi. This is students cos 2n pi. Cos 2n pi is 1. So this is students 2 to the 4 pi square upon n, and cos 2n pi is 1. Next student, this is 2 to the 4. This is 4 pi. But the value of sine 2n pi is student, this is 0. Next, this is cos 2n pi. Students, this is 2 upon n ka cube, and cos 2n pi is students, this is 1 minus cos 0 is also students 1, so this is 2 upon n k cube. This is minus 2 upon n k cube, this is plus 2 upon n k cube. So rest students, there 1 pi is cancelled, so last term is this is students 4, this is 1 pi left upon n. Here students, we are putting a0, an and bn in the equation 1. This is equation 1 students. So finally, we putting a0, an and bn in equation 1. We get students finally 1 upon fx. Here a0 is students, this is a0, 8 pi square upon 3. So we replace. So this is 1 upon 2, and the value of a0 is students 8 pi square upon 3 plus summation of, this is summation of n equals to 1 to infinity, and the value of students an, the value of an is 4 upon n square and cos n x, plus finally students n equals to 1 to infinity, and the value of bn. Here this is the value of bn, this is minus 4 pi upon n, and so putting the values of a0, an and bn in equation 1. This is the value of a0, this is the value of an, this is bn. square upon 3 plus summation of n equals to 1 to infinity an. This is simply students 4 upon n square in and cos n x plus summation of n equals to 1 to infinity and bn is minus 4 pi upon n into sin n x. It also implies students this is 2 4 8, so it is 4 pi square upon 3. This is students constant, so we can common, this is 4 summation of n equals to 1 to infinity and rest is cos n x upon n square. Here the constant is students 4 pi, common करेंगे. This is n 1 to infinity and rest is sin n x upon n. So this is the required